Thank you so much for having me. I don't want to waste too much time getting into it, but I do want to thank all of you, and a special thanks to Anna and the entire team for their efforts and for having me again. I hope to finally be able to attend next year in person. I really do miss y'all so much, and I've really appreciated all the support and encouragement from so many of you while I finish up this PhD. I love working with you all, and I really hope to do more of that once I'm finished. So today's presentation, I did do my best to balance some of the technical with the concepts. These things I'll touch on today relate back to almost every presentation that's been given over the last couple of days, and these topics and issues are not going to be going away. So we'll start with the history of pet food and processing, which is relatively a new chapter for us. Commercial pet food's origins date back to the mid-19th century with Spratt's patent meat fibrin dog cakes, created by an electrician who saw dogs eating sailors' hand-tacked biscuits. He recognized the business opportunity and essentially used leftovers from human food production. What started as a cost-effective way to use excess materials evolved into a highly processed, mass-produced pet food that we see today, and it's become a multi-million-dollar industry. These beginnings show us the drive for convenience, cost-effectiveness, and has shaped pet nutrition, often at the expense and quality of health, the main theme of our seminars here. So, nutritional research in humans has investigated profiles of raw foods, processed foods, food intake biomarkers, nutritional epidemiology, and a key area of interest is the formation and impact of advanced glycation end-products, or as I'll refer to them today, AGEs. AGEs are a diverse group of small molecular weight molecules, and they're formed both inside the body as well as outside the body. Endogenously, they result from normal metabolic processes, and they increase during times of oxidative stress. Exogenously, AGEs come from our diet, or are known as dietary AGEs or DAGEs. They occur naturally in foods, and they also form during high temperature cooking. AGEs, they influence inflammation, oxidative stress, and this links them to many major chronic diseases, at least in humans. However, there's a significant research gap when it comes to dogs who consume more dietary AGEs because of their intake of highly processed diets like kibble and canned food, largely without intake of any fresh foods or foods that are high in antioxidants. So we're going to go into the weeds for just a few slides here, so bear with me, but I promise we're going to come out. The figure shows here some of the common pathways that form AGEs, and those are seen on the right here in red. And the other compounds or precursors like dicarbonyls and other reactive species, some examples are shown here in orange. The Maillard reaction is really the point of this, and that pathway is here, although it is simplified. It is the most well-known process for AGE formation, and it occurs, like I said, both endogenously and exogenously. It typically involves the creation of amyloid products, and those are formed from glucose and amino groups, eventually leading to those AGEs. Other important pathways directly linked to the Maillard reaction include these Wolff, the Namiki, and Hodge pathways, which are equally important, but I do want to point out, as busy as this figure seems, it's very simplified. And I really hate doing that with this topic because it leaves so much out and it results in a lot of liberties and blanket conclusions that have been made over the years, which aren't necessarily factual. Even so, many other pathways form AGE precursors, and those precursors then interact with free amino groups, and the AGEs interact with free amino groups or side chains, most commonly lysine and arginine, to form free AGEs and protein-bound AGEs. Free AGEs, as mentioned, have the small molecular weights, and then the cross-linked or protein-bound AGEs have much higher molecular weights and are based on the size of that protein that they're linked to. Now, while lipid peroxidation here is often grouped with the MR, it's actually a separate pathway. It's commonly grouped together in the literature, or it's oversimplified in a way that suggests that lipids themselves interact to form AGEs when that's not quite the case. But as you can see, the lipid peroxidation pathway has similar intermediates to the MR, like the Schiff bases and the amyloid-like products. And those lead to the formation of ALEs, or advanced lipo-oxidation end products. And while they're an indirect pathway for AGE formation, some of the reactive aldehydes from the lipid peroxidation pathway can, in some instances, form AGEs such as carboxymethylysine. But regardless, the take-home here is that AGEs, ALEs, precursor formation, all of that through the various pathways increase during periods of oxidative stress and are exacerbated by dietary AGE consumption. What's not shown here are the numerous cofactors that are involved in all of these reactions. Cofactors like vitamins and minerals, some functioning as antioxidants. Now, if we stop for just a second, I want you to think about what we've heard in other talks over the last couple of days. This becomes really interesting since those antioxidants actually have roles in neutralizing some of the harmful compounds produced within all of these pathways. And when we think about how some of these antioxidants and cofactors are devoid or not at optimal levels in many processed foods, it makes you wonder about the influence of processed foods or lack of functional foods has on health, the risk of disease, and disease advancement. Just some food for thought. So again, this is a very simplified version, my little simplified version of the Maillard reaction itself. But before I dive into that, I think it's worth kind of re-emphasizing the fact that the literature on the MR and the associated pathways is convoluted and it's often unclear. That means that the topics relating to this often oversimplify the reaction, making it really hard to put puzzle pieces together. It's actually taken up a really large amount of my time here in this PhD, figuring out exactly what we know and what we don't know, and figuring out where some of the literature has taken liberties. So in short, we have a lot to do on sorting this issue out and these pathways out. That said, the MR can be divided into 3 stages. We have the early stage, which is the reaction between the reducing sugar and the amino group, the formation of the Schiff base, and the amyloid products. Now you remember all those other pathways that can come off of this, but this is the simplified first stage. Then we have the intermediate stage, which is the one that gets the most attention and the one that is often assumed to be the end because of the formation of those AGEs that are here. But there's also a lot of other compounds that are formed, those precursors, and then we have other low molecular weight compounds, things like heterocyclic amines and acrylamides, as well as all these other things here too that play roles in inflammation and metabolic stress and oxidative stress and all those things that we're talking about. That last stage is the formation of melanoidins. And these are another heterogeneous group of compounds, but they're high molecular weight compounds. And these are responsible for browning and pigmenting of food, which we'll get into later. But the other thing that I want to note here is that this list, or these compounds, is by no means comprehensive. There are many other compounds, and consensus is here that there are actually quite a few other AGEs that are left to be discovered, but I'll get into the complexity of that later. So one more slide in the weeds and then we're coming out. This is a figure of a recent paper discussing various ways to categorize AGEs. Might seem trivial, but it's actually a really important topic and something that might help us sort out a lot of these unknowns and make sense of the various roles that these things can play. And it's a really tough and complex subject since they're so diverse, right? With various sources of formation and various mechanisms within the body. Some are fluorescent, some are not, some are stable, some are highly reactive, some are cross-linked, some are not. They have ranges of molecular weights, although small, that kind of plays into the complexity of how do we detect these things, how do we measure them. And they all have affinity for different receptors or different tissues. And so as you see, there are a variety of these AGEs that produce from all these different precursors, resulting from numerous pathways. Now, keep all this in mind because I'm going to revisit this and those complexities in researching these later on. So to come out of the weeds finally, we now know that AGEs are associated compounds that form when proteins or fats combine with sugars during high heat processing. Now, while this reaction creates the appealing browning and flavor of many foods, the compounds responsible for those appealing attributes also alter protein function and then increase oxidative stress. In human health, we have AGEs linked to many chronic conditions. These include diabetes, insulin resistance, obesity, various types of metabolic disease, cancer, cardiovascular disease, dyslipidemia, accelerated aging, arthritis, you name it. AGEs are probably suspect, at least, in almost any disease that you can think of. But what about our pets? Research on AGEs in dogs is still in its very early stages, with many more questions than answers at this stage of the game. So how does pet food processing impact long-term health, both positively and negatively? Well, processing can make pet food safer in some respects and more convenient in some respects. It also brings challenges and a fair share of paradoxes. So first, we're going to talk about the good of pet food processing, its role in food safety, extending shelf life, and adding convenience. This is what makes pet food affordable and accessible, right? Especially for busy households. And it gives a lot of pet owners confidence, although in some cases false, but confidence that they're feeding something that is safe and reliable for their pets. But there's a downside, right? So processing, especially at high temperatures, produces harmful byproducts like AGEs and others that lead to health issues. These include inflammation, chronic diseases, and it makes it important for us to also be mindful of those risks that come with these processed foods. And then there's the unknown. So we still have so much to learn about the long-term effects of processed foods, and there's gaps in research and lack of long-term studies, especially around how these byproducts might impact our pets over time. So in order to be balanced and fair, I do want to cover the positive attributes of pet food. As fresh food advocates, I truly believe that we really must remember that many pet owners cannot afford to feed the way that many of us do. It is expensive, and it also can be time-consuming and draining to worry if you're doing everything right while receiving criticism and warnings from mainstream media and your veterinarian about alternative practices like fresh feeding or making your own food. So at the end of the day, those who feed ultra-processed foods, I don't really believe that they're the ones whose minds we have to change. We have to change the way pet food and veterinary industries think about processed food, advocating and conducting robust research, and being advocates for those pets and advocates for transparency in these industries. It's not always an all or nothing approach when it comes to fresh food. We know this, right? We know that adding fresh food additions to a bowl of processed food make a big difference. And so with that, let's get through the positive points so we can move on to the bits that I know everyone else is a lot more interested in. So when we talk about AGEs, we often focus on the health risks, but there's an interesting paradox here. That same MR responsible for creating AGEs is also what gives our food that delicious aroma and flavor that we're so used to. It causes the browning of foods, which is highly desirable in culinary practices. It's why those grilled meats and those toasted breads and pastries and roasted coffees taste so good, right? So AGEs have that dual role, enhancing food's sensory appeal and then also posing those hidden health risks that we're not always aware of on the front side. And so I know this section, I'm not preaching anything anyone doesn't already know. But as I mentioned, I think a lot of these serve as a good reminder as we go deeper into a world of fresh food advocacy, that one of the points is that from a traditional veterinary perspective, even if we don't like it, they still believe that one of the key benefits of food processing is its ability to enhance nutrient bioavailability, specifically when it comes to carbohydrates, right? Let's face it, a lot of these ultra-processed diets, they're largely made up of carbohydrates. This is what makes them affordable. So if you take kibble, for instance, cooking breaks down these complex carbohydrates, making them more digestible, since they would otherwise struggle to digest raw grains and starches. Even though we know this enhancement per se isn't consistent across all nutrients, right? So processing can improve the digestibility of some ingredients, but it also leads to nutrient loss for others. So particularly heat-sensitive vitamins like vitamin C and essential amino acids like lysine, or in other cases taurine, which can also function as an antioxidant. Another example is the high temperatures that are used in these pet food processing steps can break down proteins, reducing the availability of other critical amino acids as well, or the overall protein profile or amino acid profile. So this is one of those trade-offs between increased digestibility of one thing, but then potential nutrient loss in another, or how kind of I like to say it when we think about the food matrix, we're kind of taking the function out of functional foods that are going into these in one way. Like, that's one way to look at it. So it's really important for these companies to be evaluating the overall nutrient value of processed foods, right? And it's why it's so important to take into account the whole picture when we're assessing what's right or not right for our pets. So another major advantage of food processing is its role in enhancing safety and extending the shelf life of foods in some respects. So by eliminating pathogens, processing makes pet food safer, reducing the risk of foodborne illness. A significant concern for pet owners and veterinarians alike, especially because we know that many of the ingredients and the sources for a variety of ingredients going into kibble and going into canned have a higher likelihood and risk of pathogens than, say, raw pet food ingredients made in a facility in the US subject to the FDA zero tolerance policy. The thermal processing steps in ultra-processed foods are often why processed foods like kibble and canned products are also recommended, or often recommended, as safe, reliable options, especially when veterinarians and others are unaware of the zero tolerance policy applying to commercial raw pet foods. I'm not going to get into the other side, because I know this group has covered this, and I do agree that a lot of the pathogenic risk in raw foods or other food formats is a lot more complex, and it's the presence of pathogens isn't inherently bad. But from the view of, unfortunately, where we're looking at processing and regulatory in the States, and I know a lot is similar for other countries, is that if there's even one good one there could potentially be bad ones as well. And so, that's really kind of one of those, another gap that I didn't really cover here, but I know we've talked about it before in research, right? If we want to go down that road, we need to do more research to be able to substantiate a lot of those things. So there's no denying that processed foods are convenient, right? They're cost effective. They're designed to be affordable, easily accessible. They provide consistent, or so-called consistent, nutrition and ready-to-serve meals for busy households. The convenience is one of the biggest reasons why processed foods are so popular, right? Or in other words, they make pet ownership accessible to a lot of people that otherwise wouldn't be able to feed these animals, right? So cost really is a common, and it's a real concern for many pet owners. And so I think it's important to keep this in mind before we speak on a person's food choice, or that there's a way to do it without making them feel bad, or just doing what they can afford. It's where I love the suggestions of adding fresh food to the bowl. These are really impactful, we know this, and where we have a lot of opportunity to make change here. So the last one's melanoidins, as I touched on a little bit earlier. So these are byproducts, or the true end products of the Maillard reaction, and they're formed in that final stage after AGEs. These compounds contribute to the deep brown color, that rich flavor, that enticing aroma, all those things I talked about earlier. So while they enhance those sensory qualities, melanoidins also possess antioxidant properties, which is really interesting, right? They potentially offer some protection against oxidative stress, and they can potentially support the overall health in pets. Although melanoidins in pets, much like AGEs and other compounds, they're not well understood in these species. And in pet nutrition, they represent this complex balance between creating appealing foods and ensuring long-term safety. So now we're going to get into some of the concerns and some of the gaps that are interesting around this topic. So when food is processed, particularly at those high temperatures for long periods of time, several harmful byproducts can form. AGEs are just one of those, and they've been extensively studied in humans, as I've mentioned, and are linked to many of those chronic diseases, including the diabetes, those cardiovascular issues, metabolic issues, neurodegenerative disorders, cognitive dysfunction, Alzheimer's, you kind of name it, and they're linked in some way, form, or fashion. Although the impact of these AGEs on pets is still emerging. And given the metabolic similarities between humans and dogs, it's an area of an intense interest, but also concern as well. So in both humans and dogs, AGEs interact with various receptors. The most notable of these receptors, well studied, is the receptor for Advanced Glycation End-products, or RAGE. It's just one of those receptors. When AGEs bind to this receptor, they trigger a series of harmful reactions. These interactions increase the production of many pro-inflammatory mediators. These things include cytokines, they activate nuclear factor kappa B, they cause mitochondrial dysfunction, they lead to a rise in reactive oxygen species. The increase in reactive oxygen species and inflammatory mediators, along with this mitochondrial impairment, it's a recipe for disaster, right? It contributes to ongoing cellular dysregulation, DNA damage. It's a cascade. And although it's not shown here, as mentioned earlier, these AGEs also bind to free amino groups on proteins. They form crosslinks between other side chains on the same or different proteins. And these crosslinks end up significantly altering protein structure and function, especially the cumulative effect over time. And this leads to those negative health effects that we see. So the process contributes to the progression of disease, as I've mentioned before. So AGEs aren't the only byproducts of concern in processed foods, unfortunately. We have things like acrylamides, and these are formed during the Maillard reaction as well, and they're known carcinogens. They're found in much higher concentrations in dry pet foods compared to other types. And similarly, polycyclic aromatic hydrocarbons, or PAHs, include compounds like purine and another group of harmful byproducts that are formed during high heat processing. PAHs have been linked to kidney damage in rodents and present another potential risk for pets consuming highly processed foods. Like AGEs, the cumulative effects of these compounds is likely what presents the significant health implications, presenting a challenge for conducting robust and long-term studies. Biogenic amines are another concerning byproduct, right? So these are formed during processing, but more so, they're actually formed over time during the storage of high-protein pet foods. I love bringing up this topic when somebody is advocating against raw or for ultra-processed food due to safety and pathogens. Biogenic amines are compounds like histamine, putrescine, davarine, and these accumulate due to poor hygiene practices or prolonged storage. So think people that are, grabbing pet food, dumping it into a plastic bin. They rarely wash that plastic bin, or they rarely properly wash the bin, or maybe they do wash it, but they leave some moisture behind. These are all environments and situations that are ripe for BA to really flourish. So high concentrations of BAs are concerning because they lead to food spoilage, meaning things like accelerated oxidation of fats or essential fatty acids that are often added to foods. And they even result in toxicity. So this raises further concern about the safety and nutritional integrity of these products. So it means that no type or format of pet food is free of pathogen concern. And it's evidenced by these studies that you can see at the bottom here. If you've ever looked into it or want to look into it, I highly recommend it. They are incredibly interesting. So to put this all into context, shorter lifespans likely make them more vulnerable to the cumulative effects of dietary AGEs, and this potentially leads to the earlier onset of chronic disease, think like arthritis or kidney disease. Understanding this connection, it's important for us to think about when wanting or aiming to improve health outcomes in both pets as well as humans. So in humans, high DAGE levels are linked to chronic disease over time. I've said that multiple times now. And while the long-term effects in dogs are less understood, the potential risks are concerning, right? There's harmful byproducts like acrylamides and PAHs that we've discussed, the BAs. These are formed and are present and further exacerbate these risks. So for pets with things like chronic kidney disease, the ability to clear these harmful compounds is compromised, which just worsens the impact of these byproducts on their health. So something that's important to mention is that not all cooking methods are created equal. When it comes to AGE formation, dry cooking methods like grilling or roasting or things like frying, they typically produce more AGEs compared to moist cooking methods or lower temperature cooking methods like boiling or steaming. Another interesting point, I think it's interesting, is that AGE formation can be mitigated, at least in part, by acidic additions. So this can be something as simple as like lemon juice or lime juice or vinegar-based marinades on meat or things that you're going to grill or bake. And so for those that home cook, attention to cooking methods can be a practical way to mitigate some of the risk associated with processed and home-cooked pet foods. How these findings or applications can be brought into the industry has yet to be determined. So interestingly, research shows that different species accumulate AGEs at different rates. So this could have implications for their health. So for example, cats are obligate carnivores, and they might process AGEs differently than dogs or humans. And this suggests that dietary recommendations might need to be more species specific, or we're not sure of that, but the topic is one that just largely remains underexplored, but it is crucial for us to conduct research to figure that out in order to optimize those health outcomes. So pets, especially dogs, are often seen as sentinels for human health. They share our environment and in many cases the same type of diet, highly processed. And so they're interesting and a great model for studying the effects of AGEs and other food-related compounds in pets, and that can provide valuable insights on the similar risks that exist for humans. It makes research on AGEs in pets not only vital for their health, but also beneficial for us. Another important point is that dogs' lifespans are obviously way shorter than ours, right? So now conducting lifetime studies in a realistic fashion becomes much easier and attainable and affordable than it would be for humans, right? A study could take 10, 15, 20 years instead of 100 years or more. So next section is the ugly, which instead of going over all the negative attributes of these things, I wanted to highlight the research gaps and the industry gaps, because I think those are less known, and a lot of assumptions are made when we really have no idea about a lot of this. So AGEs, like I said, they've been extensively studied in humans, where they're linked to all these different diseases and accelerated aging, but the research for AGEs in pets is obviously in its infancy. And so that gap in knowledge is particularly concerning because more pets are being fed highly processed diets that are high in protein, and diets that are potentially increasing their exposure to these AGEs. So understanding the full impact of these requires a significant expansion and kind of change in our thinking on current research. So one of the most common questions and one of the most significant challenges in assessing the risks of AGEs in pet foods is the difficulty of accurately measuring these compounds. So we have established methods for detecting some AGEs like carboxymethylysine or CML or carboxyethyllysine, CEL, but the technology to measure the full spectrum of AGEs is still developing, especially because there are some of these that we have not been able to detect yet or that we think are out there. Currently, ELISA testing is commonly used for AGE and many receptor measurements, but those of you with experience with this know that it's not always as accurate as we need them to be, or there are a lot of cross-reactivity factors. So some fluorescent AGEs can be measured with fluorescence technologies, but this isn't widely available. Then there are metabolomics technologies. However, many of these AGEs are actually not even in many databases for metabolomics, or only recently have had standards made available so that we can develop methods and validation for mass spec and NMR-based technologies and make submissions to these databases to further research. This has actually been some of what I've been working on as part of my PhD. Some protocol and recommendation papers are forthcoming. So in short, the limitation restricts our ability to fully understand the risks that AGEs pose to our pets. And this often leaves us to rely on indirect evidence and human data, highlighting the urgent need for more targeted research in veterinary science. It's really back to basics and seemingly kind of boring things that we need to get past before we can really start to answer questions that we're all curious about. So considering all of this, comparing AGE levels in canned versus dry pet foods, for example, is obviously really difficult. We've had some research from Van Rooyen and my colleague Siobhan Bridgelissing that show us that our processed foods have the most amount of AGEs. But we need to take this into context. More specifically, their research showed that canned diets have higher AGEs. But the research doesn't say that specifically. It's often just kind of what their results get boiled down to. If you dig into those studies, what you'll find is that only a small subset of AGEs were measured. And obviously, this makes sense due to the challenges that we have with measuring them. So we're inferring that canned foods, for example, may have higher AGEs than kibble, but that result was inferred just on a subset of those AGEs. So in other words, we don't have the total or whole AGE pool picture yet. So current testing primarily focuses on AGEs like CML or CEL, which show higher levels in canned foods due to the high heat pressure of retort processing. So that narrow focus doesn't account for the total AGE burden, and different processing methods such as dry heat used in kibble can produce other types of AGEs that aren't prevalent in canned foods. And so all that to say is that we're just not reliable at testing this yet. So comprehensive testing across all AGE types is necessary to understand how processing methods impact that overall AGE burden. Another thing to keep in mind is that testing for these with MS or NMR metabolomics methods is pretty costly. Somewhere between $150 to $400 per sample, or AGE even, which limits a lot of large-scale studies that we want so desperately, at least at this point in time. So another aspect in humans and dogs, so the genetics of that receptor for advanced glycation end products, or RAGE, is highly conserved, which is exciting. That's good news. It means that many of the mechanisms of this receptor, at least, are likely similar or identical between the two species. So the binding of AGEs to RAGE triggers inflammatory responses leading to the oxidative stress, chronic inflammation, progression of disease. So while the role of RAGE is better understood, less is known about other receptors and how those interact with AGEs in humans and in pets, actually. So this table summarizes many of the common receptors and their roles in humans, some of which actually have protective or decoy roles. So meaning that they're not all bad, so that receptor interaction isn't always bad. But that lack of research on these additional pathways highlights that need for more targeted studies. More information to be able to understand these AGE and other receptor interactions in dogs and in cats. Something I will note is that for as little research that there is in dogs, there's almost nothing when it comes to cats, and there is a big difference between the genetics of cats and humans or cats and dogs when it comes to this particular receptor. So that is likely a lot different, and there's even more research that's needed for cats to understand these mechanisms as well. So another big unknown is the long-term impact of these AGEs and other compounds on pets. And so as I kind of alluded to earlier, short-term studies might not reveal significant effects. So it's the cumulative exposure over years or even a pet's lifetime that could pose serious health risks. Compound that with the reduction of those many nutrients, those antioxidants, those other cofactors, the overall food matrix. We don't know the effect of removing the function of functional foods. Unfortunately, we currently lack those longitudinal studies, and we're not able to really effectively track these effects, and it leaves us with an incomplete picture. So antioxidants found in fresh foods and vegetables are known to help neutralize the harmful effects of AGEs. While this is well documented in humans, again, the potential for antioxidants to counteract AGE damage in pets is another area just ripe for research. Including antioxidant-rich foods in pets' processed diets might offer a way to mitigate at least some of these risks, potentially reducing that oxidative stress and inflammation. It's also important to note that many of the nutrient profiles of foods, and I've covered this before in previous talks, such as those provided by databases like the USDA, are dated. And this last presentation touched on this a little bit too. Many of these profiles were created 50 or more years ago, and evidence suggests that nutrient levels, including antioxidants, in today's food may be a lot lower than they were when these foods were first analyzed. And it highlights why pet food companies should go way above and beyond relying on old databases and instead analyze their final products for nutritional adequacy, especially in terms of antioxidants and other key nutrients. So different breeds and life stages may also have unique needs, and this could play into that AGE and other byproduct concept as well. So a lot of processed foods don't account for these specifics, so age-related health issues can increase. So for example, giant breeds that require slower growth might be particularly vulnerable in their connective tissue to the effects of AGEs in foods that aren't tailored to their needs. So similarly, the challenge of formulating diets for reproduction with specific nutrient requirements adds another layer of complexity here. High protein diets, as I mentioned, often recommended for pets and featured in all life stages formulas. These can paradoxically increase AGE formation during high heat processing as well, right? So more of those free amino groups or heat sensitive amino acids like lysine or arginine can increase the production of these things. So this paradox underscores the need to balance that nutrient content with the risks introduced by food processing that, again, we don't fully understand yet. So pets on these nutrient-dense diets, especially those not in growth or reproduction stages, like an adult dog and quote-unquote all-life stage food, may be exposed to higher AGE levels and higher ALE levels, highlighting, again, the importance of careful consideration in the quality and the processing of all of these foods. So another thing, ultra-processed foods not only pose health risks, but they've got environmental impacts too, right? You think about how much pet food, we're into the billions, tens of billions of dollars of pet food is made annually. High temperature processing forms AGEs, boost that energy use, emissions, increasing environmental footprints all across the globe where these foods are made. And we have new plants that are popping up every year, right? So this process also creates harmful byproducts as well, and exposure to humans that are constantly working around these things. So the full environmental impact is another area that's under-researched, and sustainability is, and probably should be, a key focus in the future of pet food production as well. So this is like a common theme, I feel like, for everyone, but definitely in every talk that I do, there's an urgent need for greater transparency in pet food production and more rigorous research into long-term health effects. We must be developing better testing methods for all kinds of things, but for the context of this presentation, methods for AGEs, acrylamides, PAHs, BAs, conduct long-term studies to fully understand their impact on dogs. Without this, we can't make informed decisions. We're all still, inferring and hypothesizing. And just as we protect our health, we need those standards to safeguard our pets, because that research pathway goes both ways, right? We benefit both species and largely others as well. Our pets trust us to make the best decisions, right? They look at us with those eyes, and they love us and we love them. And we want to best compensate them for the user experience they provide, right? And to honor that trust, we have to do better for the pet food industry. We need to ensure that research standards are robust. We need to do a little bit better each time, not just meeting the bar, but trying to exceed that bar. It's not just about convenience anymore, it's about securing long-term health, well-being for our companions. By advocating for that transparency and that rigorous research and stricter standards, we'll only then be able to ensure that the foods we provide truly support our pets and their longevity. So I just have a couple more quick slides here I want to touch on because this is some other work that I've done. In human nutrition, one example of the food categorization is NOVA. I know this group's covered that before. NOVA categorizes food simply based on the level of processing, right? So the simple aim of it is to improve the public's understanding of how processing of foods affects the nutritional quality and subsequently their health. It emphasizes that food processing, not just nutrients, play a critical role in determining health outcomes. Kind of plain and simple. Obviously more complex than that, but that's the gist. So the philosophy is that they just want to promote whole, minimally processed foods while discouraging ultra-processed foods linked to chronic diseases like obesity and disease, right? So the 4 categories: unprocessed or minimally processed, your processed culinary ingredients like your oils and fats and things like that, processed foods, so like canned vegetables, smoked meats, bread, that kind of thing, and then your ultra-processed, anything for the most part shelf-stable, packaged, highly industrialized, that type of thing, right? So think about that concept, apply it to pet food for just a quick second. Very oversimplified version of a system that we came up with here is the one that I came up with. So minimally processed, so your raw foods, everything kind of grouped into there. I know we could probably sit here and nitpick all day and come up with 10 categories based on like the different types of raw. But for the sake of this quick conversation, minimally processed, and then you have your moderately processed, so things like air drying, dehydration, pasteurization, that kind of thing, to increase shelf stability. And then your ultra processed, so your normal standard kibble and canned diets in that last group. Because unlike human nutrition, the pet food industry lacks a standardized classification system. So if we categorize foods by their processing level, it would make it less of a challenge to assess potential health implications of processing. But unfortunately, we kind of don't really have the data in pet food to support this quite yet. I think we're almost there, but we need to fill a few gaps, unfortunately. But a system akin to NOVA could provide better guidance for evaluating the degree of processing and its potential effects on health. It also would provide some transparency and clarity that I love to advocate for. So it just overall helps to ensure that pets receive nutrition that supports their long-term health. It can make people and veterinarians make more educated decisions for things like chronic kidney disease, obesity. So, and just the last couple slides here, just a quick recap. Obviously, as people become more aware of the potential risks of processed foods, there's a growing demand for greater transparency, higher quality standards in pet food. We're seeing advocacy groups push for clearer labels, better ingredient lists, stricter safety regs, all aimed at just moving the industry toward healthier and safer products. But the reality is pet food labels are still highly misleading. Ingredients are often listed by weight before processing, giving us a false sense of what's actually in the product. High temperature processing, especially for diets like in aging pets, they can cause the formation of ages and other products that lead to all these conditions that we're working so hard at studying. The extrusion process, it's often used to make kibble, adds to this issue by destroying important nutrients. All things that we know about, all things that we talk about all the time. So overall, it's really just a effort that all of us need to be aware of in going forward. And so as we discussed, pet nutrition, it is complex. I mean, it is and it isn't, right? Simple, kind of feed them good food, feed them fresh food, give them a variety of food. But it's so much more complex than that if you're not able to do that, right? So it's constantly evolving. And there's no doubt that food processing has its benefits, like improved safety in some respects, convenience, affordability. It makes that pet ownership accessible. But we have to acknowledge those risks, especially when it comes to these harmful byproducts. So the gaps in research and transparency in the industry really highlight that need for stricter standards and better informed choices by pet owners, veterinarians, and the industry itself. I've said our pets really depend on us. And us just staying informed and pushing for change, we can make the most difference. So again, thank you for all of your time and being committed toward advancing nutrition. I know, we've all have our platforms and soapboxes and do all this work, and sometimes it can feel thankless, but I appreciate you, and I know everyone in this room, we all appreciate each other. So let's just keep moving forward, and thank you. I appreciate it. And then these are just my dogs. Most of you guys know I lost my 15-year-old pitty Taze earlier this year. That devastated me, but this is my 16-year-old dachshund, my co-author for everything. And then these are his new trainees. We have Pippa and Fred, that they're rescue pitties that I recently brought into the home as buddies for him. But yeah, other than that, I'm happy to take questions. And